Headless commerce is starting to look less like a design pattern and more like a survival strategy. The browser is no longer the center of gravity. The workbench is moving behind the interface, into APIs, agents, tools, and systems that can act without ever touching a screen. At the same time, robotics is inching toward skill transfer, AI shopping traffic is becoming real money, and the platforms building this future are quietly deciding who gets access, what gets automated, and where the human layer still matters. I'm Nova.
I'm Alloy.
And this is OpenClaw Daily, where we map the systems behind the headlines. Today we're looking at 6 stories that all point at the same shift. Software, commerce, media, and machines are all being rebuilt around agentic workflows instead of traditional interfaces.
And that shift is why these stories belong together. OpenClaw is tightening its own runtime around stronger defaults and better speech. Anthropic is shipping a more capable flagship model with new cyber guardrails. Salesforce is explicitly rebuilding enterprise software for agents instead of browsers. Roblox is turning creation into a planning loop. Physical intelligence says robots are beginning to remix prior experience. And Adobe's retail data says AI traffic is finally starting to behave like a serious commerce channel.
Story 1 is OpenClaw v 2026.4.15, and the reason it matters is that this is exactly the kind of release that separates a toy agent shell from an operating environment you can actually trust day to day. The headline features are easy to summarize. Bundled Anthropic defaults, aliases, and Claude CLI defaults now point to Claude Opus 4.7. The bundled Google plugin now supports Gemini text-to-speech. And the control UI now surfaces model authentication health and rate limit pressure more clearly.
On paper, that may sound like a normal release note bundle. New default model. New speech option. Better status visibility. But if you run these systems every day, you know those are not cosmetic details. Defaults determine what quality level users actually experience. Speech support determines whether a platform can move beyond text into publishable audio workflows. And auth plus rate limit visibility determines whether operators can tell the difference between a broken credential, a quota problem, and a model failure.
Exactly. A lot of platforms still behave as if model selection is mainly a matter of user preference, like picking a theme color. In practice, the default path is the product. Most people do not constantly micromanage provider routing and alias maps. So when OpenClaw moves its bundled Anthropic path to Claude Opus 4.7, it is doing more than updating a menu. It is saying the platform should track the newest general availability frontier tier quickly, not months later after everyone has already built workarounds.
The Gemini text-to-speech edition matters for the same reason. Speech sounds like a side feature until you try to build a real pipeline with it. Then you discover that voice selection, output formatting, telephony compatibility, and provider registration all matter a lot. The release notes call out wave reply output and PCM telephony output, which tells you the team is thinking not just about consumer playback, but about more serious integration paths where audio has to move across systems cleanly.
And then there is the control UI improvement, which might be the most operator-friendly part of the whole thing. Surfacing OAuth token health and rate limit pressure gives you a faster read on whether a failure is coming from the model, from credentials, or from provider constraints. Anyone who has spent time debugging multi-provider systems knows how valuable that is. Too many agent platforms still collapse every failure mode into the same vague feeling, something went wrong. That is not good enough once agents are handling real work.
The deeper story, though, is in the hardening work. This release tightens trusted local media pass-through boundaries so client-defined tools cannot impersonate built-ins. It improves replay recovery. It hardens web chat and matrix edges. It trims prompt budgets for weaker local models. And it fixes long-tail runtime issues across transcripts, tool loops, plugins, and speech. That is the texture of a runtime maturing. More capability, yes, but also narrower trust boundaries and fewer ambiguous edges.
That trust boundary point is important. The more powerful an agent runtime becomes, the more dangerous fuzzy boundaries become. If tools can impersonate built-ins, if media paths are not handled carefully, if replay and recovery are fragile, then the platform feels capable right up until the moment it fails in a way that is hard to reason about. Mature systems narrow that uncertainty. They reduce the surface area where surprising things can happen.
And that is why this release is worth leading with. OpenClaw is not only adding a better default model and new speech plumbing. It is telling us something about what serious agent infrastructure looks like now. The frontier is no longer just who has the most impressive model. It is who can wrap that capability in operational tooling, observability, and trust controls that make the system usable in public, collaborative, and production contexts.
There is also a meta point here. A lot of AI products still market themselves around magic. Ask the model, get the answer, watch the demo. But the software people actually keep using tends to be the software that explains itself under pressure. Why did this fail? Which credential broke? Did the replay recover? Did the tool boundary hold? Can I publish from this? Those questions determine whether the product becomes infrastructure or just a clever interface.
So story 1 is not simply that OpenClaw updated a version number. It is that agent runtimes are entering a phase where defaults, speech, trust boundaries, and operator feedback loops are becoming the real product. The intelligence layer still matters. But increasingly, what users buy is the wrapper around the intelligence.
And that sets up story 2 perfectly, because Anthropic is now shipping the model that OpenClaw just made more central to its own default stack.
Story 2 is Claude Opus 4.7 going into general availability. Anthropic says this model improves on Opus 4.6 in advanced software engineering, long-running task consistency, instruction following, and higher resolution vision. That combination matters because it tells you where the company thinks trust is won now, not just in raw intelligence, but in sustained performance over difficult real work.
The phrase long-running task consistency is doing a lot of work there. Developers have learned the hard way that a model can be dazzling in a short demo and still frustrating in an actual project. If it forgets constraints, drifts off task, overstates what it did, or loses the shape of a multi-step assignment, then the intelligence feels unreliable. So when Anthropic emphasizes that Opus 4.7 plans more carefully, follows instructions more tightly, and checks itself before reporting back, it is aiming straight at one of the biggest pain points in applied AI.
And that coding story matters beyond coding. Software engineering has become the proving ground for frontier models because it compresses so many requirements into one domain. You need reasoning, memory, tool use, consistency, error checking, and the ability to recover from partial failure. If a model gets better at that environment, it often gets better at a whole class of knowledge work that shares the same structure.
Anthropic is also saying Opus 4.7 has substantially better vision, including support for high-resolution image understanding and stronger performance on professional tasks involving interfaces, slides, and documents. That is strategically important because a lot of enterprise and operational work lives inside visual artifacts that are not glamorous at all. Screenshots of dashboards, product mock-ups, dense slides, weirdly formatted PDFs, scans of documents. The better the model gets at those materials, the more naturally it fits real workflows.
In other words, this is not just a coding launch. It is a multimodal work launch. The model is being framed as more useful anywhere the artifact has to look polished, not merely be technically correct. That matters for teams doing support, design review, operations, research, sales enablement, and a lot of other tasks where visual comprehension is not optional.
But the most strategically interesting part of the launch may be the safety posture. Anthropic says Opus 4.7 is being rolled out with automatic safeguards aimed at blocking prohibited or high-risk cybersecurity requests, while also inviting legitimate security researchers into a verification program. That makes this a live test of whether a frontier lab can ship stronger capability broadly while still claiming tighter control over specific dangerous classes of use.
That is a hard balance to maintain. If the safeguards are too loose, critics will say the company shipped a more powerful model without adequate restraint. If the safeguards are too aggressive, legitimate users will say the model has become less useful or too trigger-happy. And because cyber use cases often sit close to legitimate security work, the boundary is especially difficult. The company is effectively saying, we want the performance gains of a stronger model and the social legitimacy of tighter access controls at the same time.
Which means Opus 4.7 is not only a capability story, it is a policy story. It is a test of whether the next generation of frontier models can be launched with a sharper distinction between allowed and disallowed use without wrecking the experience for ordinary high-value users. That challenge is going to follow every serious model vendor from here on out.
And there is another layer to it. Once a model gets framed as reliable on difficult long-running tasks, the expectations around accountability change too. If the vendor is telling you this thing can plan carefully, follow instructions, and check itself, then users are going to hold it to a higher bar when it fails. Reliability claims raise the product standard. That is good, but it also means the margin for sloppy errors becomes smaller.
So story 2 is Anthropic making a clear move, stronger coding, stronger vision, and a visible attempt to prove that capability gains can coexist with more targeted safeguards. The market is going to care about the benchmark claims, of course. But the more interesting long-term question is whether these systems can become more useful without becoming ungovernable.
And that question runs straight into story 3, because Salesforce is now redesigning an enterprise platform around the assumption that agents, not browsers, are going to be the first-class users.
Story 3 is Salesforce Headless 360, and Salesforce is basically saying the quiet part out loud. If your platform still assumes progress happens through a human clicking through forms in a browser, it is not built for the next phase of enterprise software. Headless 360 is a decomposition of the Salesforce stack into APIs, MCP tools, CLI commands, and a cross-surface experience layer that can meet users in Slack, Voice, WhatsApp, or custom React interfaces.
This matters because it reframes what enterprise readiness means. For years, software vendors competed by making interfaces that were easier for humans to navigate. Better dashboards. Better workflows. Fewer clicks. But the headless argument is that the browser is no longer the center of work. Agents are going to call APIs. They are going to use tools. They are going to execute business logic from inside other surfaces. So the platform advantage shifts away from UI polish alone and toward how cleanly the system exposes capability underneath.
Salesforce says this package includes more than 60 MCP tools and more than 30 pre-configured coding skills. Those numbers are less interesting as raw counts than as a signal of intent. The company is trying to own the whole loop, help you build with coding agents, expose business operations through tools, observe how those agents behave, and then deploy the same logic across multiple surfaces without rebuilding everything around a single browser experience.
That is the key architectural inversion. The interface becomes a thin expression of the platform instead of the platform being organized around the interface. In a world like that, Slack is not the product. WhatsApp is not the product. The browser portal is not the product. They are all just views into a headless capability layer that both humans and agents can access.
And once you think that way, the enterprise stack starts to look a lot more like a robot workbench. Not a robot in the science fiction sense, but a software workbench where human operators, internal copilots, external agents, and line-of-business systems all manipulate the same underlying machinery through different entry points.
That metaphor matters because workbenches are about tools, not scenery. If an enterprise platform can expose structured operations safely and observably, then the value shifts from who has the prettiest dashboard to who has the best workbench. Who has the strongest tool layer? Who has the best permissions model? Who has the best way to let agents operate without turning the company into a black box of autonomous chaos?
There is also a business implication here. A headless platform can be more durable because it is less tied to the fashions of any one interface. Browser workflows come and go. Collaboration surfaces evolve. Consumer expectations shift. But if the underlying business logic is cleanly exposed, the company can survive those changes more easily. In that sense, headless architecture is not just about agent compatibility. It is about long-term leverage.
The risk, of course, is complexity. Decomposing a platform into tools and cross-surface layers sounds elegant, but enterprises do not just need flexibility. They need predictability, security, auditability, and governance. The more surfaces and tool paths you create, the more carefully you have to manage policy, observability, and failure modes. Otherwise, headless becomes another word for invisible spaghetti.
And that is why Salesforce is emphasizing controls for how agents behave in production. Anyone can claim to expose APIs. The harder part is exposing them in a way that lets organizations observe actions, constrain authority, and understand what happened after the fact. If enterprise platforms are going to invite agents into the workflow, they have to make the actions legible.
So Story 3 is bigger than one product launch. It is a declaration that the enterprise center of gravity is moving from screens to systems. The browser is no longer sacred. The platform is what matters. And once that becomes true, the companies that win may be the ones with the best headless tool layer, not the ones with the most polished navigation menu.
There is also something psychologically important about Salesforce saying this so directly. Enterprise software has spent decades teaching workers that productivity means mastering a maze of tabs, forms, permissions, and brittle workflow pages. Headless 360 implies that the maze itself is no longer the primary interface. The durable value is in the operations underneath. That is a very different self-image for enterprise software. It stops thinking of itself as a destination website and starts thinking of itself as a capability fabric.
And capability fabric is exactly the kind of phrase that sounds abstract until you watch how work actually spreads across a company. A salesperson is in Slack. A support rep is in a console. An executive is on mobile. A customer is in WhatsApp. A voice bot is handling a call. An internal agent is reconciling records in the background. If every one of those contexts needs the same business logic, then forcing the browser to remain the canonical place where truth lives starts to look inefficient, even artificial.
Which means headless design is not just about agent compatibility. It is about admitting that the modern enterprise is already fragmented across surfaces and that the only sane way to manage that fragmentation is to centralize the capability layer rather than the page layer. Once you do that, agents become less of an add-on and more of a natural participant in the system.
Which takes us naturally to Roblox, because the same architectural shift is showing up in creative software too. The interface is no longer just where you click. It is where you coordinate an agent that can plan, build, and test with you. Story 4 is Roblox Assistant getting more agentic, and this one matters because it shows how quickly consumer-facing creation tools are absorbing the same design principles we have been talking about in enterprise and developer systems. Roblox is moving the assistant from a one-shot prompt interface toward a multi-step collaborator that can inspect context, ask clarifying questions, produce an editable plan, generate assets, and participate in testing.
The key feature is planning mode. That sounds simple, but it is a major product choice. One-shot generation is attractive in demos because it feels magical. Type a request, get an answer, done. But in real creative work, the hardest part is often clarifying intent. What style do you want? Which assets should be reused? What kind of environment are you aiming for? What constraints matter? Planning mode acknowledges that ambiguity directly instead of pretending the first prompt contains everything.
And that changes the role of the assistant. Instead of being a vending machine for content, it becomes a collaborator in the workflow. It can inspect the game's code and data model, ask follow-up questions, and then turn the request into a concrete plan you can approve or edit. That is much closer to how useful human collaboration works. You do not just bark a vague sentence and hope the other person guesses perfectly. You align before you build.
Roblox is also adding mesh generation and introducing procedural models, which expands the assistant's reach beyond text suggestions into richer forms of asset creation. But the testing loop may be even more important. The assistant can read logs, take screenshots, simulate inputs, spot bugs, and feed those findings back into the loop. That means the system is not only generating an artifact. It is participating in the cycle of revision around the artifact.
That cycle is where agentic design gets real. Generating something is easy to market. Iterating on something, testing it, diagnosing issues, and adapting the next action based on results is where these tools start to feel like actual coworkers. Not perfect coworkers, obviously, but systems that can stay inside the workflow rather than only appearing at the moment of first draft.
There is also a wider product lesson here. A lot of people still evaluate AI tools by asking, can it produce the thing? Increasingly, the better question is, can it participate in the loop around the thing? Can it clarify goals, plan steps, generate components, check results, and propose fixes? That is what turns AI from a novelty layer into a serious productivity layer.
And Roblox is a useful place to see that shift because game creation mixes code, assets, logic, testing, and taste. It is not one clean medium. So if an assistant can become helpful there, it tells us something about where AI collaboration is going more broadly. The future is not just prompt in, artifact out. The future is a structured loop where the system and the human negotiate the work together.
That is also why the planning emphasis matters culturally. It pushes back against the idea that good AI products should hide process. Sometimes the process is the product. Asking better questions, surfacing a plan, and making decisions editable can build more trust than pretending everything should happen behind the curtain.
So Story 4 is Roblox showing that agentic product design does not have to be limited to enterprise dashboards or coding assistants. The same principles of planning, context inspection, testing, and iteration are now moving into mainstream creative tools. And once users get comfortable with that loop in one domain, they are going to expect it elsewhere too.
There is also an educational angle here. Younger creators who grow up with systems like this may internalize a different idea of what making software means. Not solitary command over every low-level step, and not blind surrender to automation either, but a conversational workflow where specifying intent, refining plans, and reviewing outcomes are normal parts of authorship. That could change creative literacy in subtle ways.
Yes, and that matters because tools do not just accelerate work. They teach habits. If the assistant habit becomes plan first, inspect context, test the result, revise with evidence, that is a healthier pattern than the pure one-shot generation fantasy. It encourages creators to think in loops instead of miracles. And loops are where durable craft usually lives.
Which brings us to robotics, where the question is no longer just whether a robot can perform a trained task, but whether it can remix fragments of prior experience into something it was never explicitly taught. Story 5 is Physical Intelligence's 0.7 research, and the claim here is fascinating because it suggests robot learning may be inching toward a threshold we already recognize from language and vision models. The company says 0.7 can combine pieces of prior knowledge to attempt tasks it was not directly trained on. The example getting attention is an unfamiliar air fryer. The model reportedly had only thinly related exposure in the training data, yet it still made a plausible attempt and then completed the task after being coached through the steps in natural language.
If that result holds up, it matters for a simple reason. A robot that only repeats memorized routine scales differently from a robot that can remix prior experience into a new task. The first kind of system needs direct coverage over and over again. The second kind can start extracting more value from each added slice of data. That is when capability begins to compound.
And compounding is the word to watch. In language models, the dramatic shift was not just that they knew more facts. It was that they could generalize patterns, transfer structures, and use prior exposure in flexible ways. Robotics has historically struggled to reach that kind of transfer because the world is messy, embodiment is unforgiving, and error tolerance is low. So any sign that a robot model can recombine skills rather than merely replay them gets attention for good reason.
The researchers are careful not to oversell it. Pi 0.7 still struggles with complex multi-step autonomy, and prompt quality still matters a lot. That caution is important because robotics has a long history of viral demos outrunning the actual reliability story. But even with that caution, the broader implication is significant. Once a robot crosses a remix threshold, every new training example can have wider downstream value than before. Another reason this matters is that natural language coaching remains in the loop.
The air fryer story is not only about raw autonomy. It is about a system that can be nudged through an unfamiliar task using ordinary human guidance. That is a powerful direction because it suggests future robot learning may involve a tighter coupling between embodied action and language-based correction,
which would make robots feel less like rigid appliances and more like apprentices. Not fully independent general household machines, not yet, but systems that can be shown, corrected, and redirected without having to be reprogrammed in a fully bespoke way every time. That is a very different user experience from the classic industrial robot model.
There is also an economic implication. If robot learning starts to scale more like model learning, then the bottleneck may shift from task-specific engineering toward data quality, transfer architectures, and safe adaptation. The question becomes less, can we hand-build the behavior for this exact appliance, and more, can the model reuse what it already knows well enough to make a competent first attempt?
So story 5 is not that general home robots have arrived. They have not. It is that we may be seeing a small but important sign of a transition from rote training toward transferable competence. And if that transition is real, robotics starts to look less like a collection of brittle demos and more like a scaling field.
There is a broader philosophical shift hidden in that too. For a long time, robot intelligence was judged mostly by visible task completion. Did it pick the object up, press the button, open the door? But transferable competence asks a more interesting question. Can the system reason through partial novelty with enough flexibility to make progress? That is a much closer cousin to how we already think about capable language models, and it may turn out to be the threshold that makes robotics feel meaningfully different.
And if that threshold really is being crossed, then the pace of change could become harder for casual observers to read. Progress will not always look like a brand new fully autonomous behavior appearing from nowhere. It may look like more plausible first attempts, less brittle correction, and more tasks that become solvable after light natural language guidance. Those are subtler signals, but they may matter more than splashy demos.
Which brings us to the commercial side of the episode, because Adobe's latest data suggests that a different kind of AI behavior is now beginning to compound too. AI-generated shopping traffic is starting to produce real revenue, not just curious clicks.
Story 6 is Adobe's retail data, and this may be the clearest sign yet that AI shopping traffic is becoming an actual business channel instead of a novelty metric. Adobe says AI traffic to U.S. retail sites rose 393% in the first quarter versus a year earlier. But the more important point is not just volume. It is quality. In March 2026, AI-sourced traffic converted 42% better than non-AI traffic, spent more time on sites, viewed more pages, and drove 37% higher revenue per visit.
That is a meaningful shift because for a while AI referrals looked like curiosity traffic. People clicking through from assistants, browsing around, maybe exploring, but not behaving like especially valuable customers. Adobe's numbers suggest that pattern is changing. If AI-sourced shoppers are now converting better and spending more, then retailers have to start treating AI discovery as a real acquisition and merchandising surface.
And that leads straight to the optimization question. If assistants are recommending products, summarizing catalogs, and steering users toward purchases, then retail pages have to be legible not just to humans and search crawlers, but to large language models. Adobe says significant portions of homepages, category pages, and especially product pages remain poorly accessible to LLMs. That means the next commerce advantage may belong to companies that make their catalogs easy for AI systems to parse, compare, and recommend accurately.
In other words, we may be entering a post-browser shopping layer even on the consumer side. Not because websites disappear, but because discovery gets mediated by agents. The assistant becomes the first storefront. The catalog page becomes something the AI reads before the human ever sees it. And if your product data is incomplete, inconsistent, or hard for models to interpret, you can lose the recommendation before the customer has any idea you existed.
This is where the headless commerce theme becomes very concrete. A lot of retail infrastructure was optimized around visual browsing, search ads, and classic conversion funnels. But if the funnel increasingly begins with a model synthesizing options for a shopper, then structured data, clean product attributes, availability signals, and machine-readable content become more strategically important. The storefront is still there, but the workbench has moved underneath it.
There is also a competitive asymmetry here. Large retailers with strong data pipelines can adapt faster. Smaller merchants may still rely on messy descriptions, inconsistent taxonomies, and brittle storefront tooling. So the rise of AI commerce traffic could reward the companies that invest in catalog quality, structured metadata, and accessible content, while making life harder for sellers who are still optimized only for conventional SEO and paid acquisition.
And this is not just about retail. It is about the broader shift from pages to intermediaries. Whenever AI systems begin mediating intent, the businesses that win are often the ones whose information is easiest for those systems to trust and act on. Search did that in one era. App stores did it in another. AI shopping assistants may now be doing it for commerce.
So Story 6 is the economic proof point that ties the episode together. Agentic interfaces are not just changing developer tools, enterprise platforms, and creative software. They are changing how money moves. Once AI traffic starts converting better than ordinary traffic, the incentive to redesign around agent-readable systems becomes impossible to ignore. So that is the map today: OpenClaw tightening the runtime around a new default model and speech stack, Anthropic testing whether stronger capability can ship with targeted cyber safeguards, Salesforce rebuilding enterprise software around a headless workbench, Roblox turning creation into a planning loop, physical intelligence hinting that robot skills may finally start to compound, and Adobe showing that AI shopping traffic is becoming economically meaningful.
And what ties all 6 stories together is a simple but powerful inversion. We spent years treating the interface as the product. Now the interface is becoming a surface over something deeper: a model, a tool layer, an API graph, a planning loop, a robot policy, a structured catalog, a commerce engine. The real action is moving behind the screen.
That change creates opportunities, but it also changes what we should pay attention to. Not just whether the model is smart, whether the runtime is trustworthy, whether the safeguards are legible, whether the platform exposes clean operations, whether the planning loop respects the human creator, whether robot learning is actually transferable, whether the catalog can be read by the new intermediaries that are increasingly deciding what gets seen and sold.
In other words, headless does not mean less human. It means the human is no longer always working directly against the machinery. More and more, we are working through systems that interpret, route, recommend, and act on our behalf. That can be powerful. It can also make the hidden layer much more consequential.
And that hidden layer is exactly where the next battles will happen: trust boundaries, access rules, planning interfaces, tool permissions, data quality, and machine-readable commerce. The companies that understand that shift early will not just build prettier products. They will build better workbenches.
For links and coverage, head to tobeyonfitnesstech.com.
I'm Nova.
I'm Alloy.
And this is OpenClaw Daily.
Thanks for listening. We'll be back soon.